this is the initial position, right? So let's define the initial position as P, right? And now this particle moves like this, right? And it is finally reaching to this final position P dash. Okay, so now let's call it like that, right? So now I will consider this as the origin, right? Right. So now this is the origin, right? So this is the x-axis, right? And this is the y-axis, and this is the origin, right? Okay. So now the displacement, right, or the distance, right, to this initial position, right, that is represented by this point P over here, right? So let's say that distance or that radial distance is r. Okay, so let's say that radial distance is r, right, and it is making an inclination theta with the x-axis, right? Okay, right. So now this is the final position, right? Now we will again try to connect this origin and this final position by kind of a length, right? Or let's call it a radius, right? So let's say something like a radius, right? So now I am going to connect this origin to the R, right? Okay. So now this particle, right, moves from here to here, right, such that this is the initial position, right? So let's call it the initial position, okay, and this is the final position, right? So now this particle moves from here to here within a time gap or within delta t period of time, right? And now here you can see there is an increment in this radial distance, right? Or let's call it that displacement, right? So let's say the present displacement from this origin, right, or the new radial length is, so let's call it r plus delta r, okay, right? Now then, but better use the term displacement rather than the distance, right? So let's say the initial displacement is r and the final displacement is r plus delta r. Now delta r is that particular change in the displacement after delta t period of time, right? So then if it is so, what is the initial radial velocity? What is the radial velocity? That means the velocity along the radial direction, if you consider it as a radius, so that will be radial velocity, right? Let's say radial velocity, so that is r dot, right? Then what is the final radial velocity? Final radial velocity, so that will be, so let's call it as r dot plus, right, delta r dot, right? So that is the final radial velocity, r dot plus delta r dot, right? Now what is the initial tangential velocity? Now what is the tangential velocity? Tangential velocity is the velocity, right, that is in a direction where the direction of the tangential velocity is perpendicular to that radius, right? This tangential velocity, if I call it as Vt, the tangential velocity that is perpendicular to this radius, right? So this tangential velocity Vt, that is given by the radius times, right, the angular velocity omega, right? So according to this initial situation, it will be r times theta dot, right? Because this initial position P is making an inclination of theta with respect to the horizontal, right? So then what is the angular velocity? So this theta dot is the angular velocity. Theta dot is the initial angular velocity, right? Right. So then what is the final tangential velocity? So let's call it as the final tangential velocity will be r theta dot, right, which is the initial tangential velocity plus change in the tangential velocity. So let's call it delta r theta dot, right? So now you got the point. The difference in the angular displacement in between the initial position and the final position. So let's call it as delta theta, right? So then what is this small angle? That will be delta theta. Understand, right? So now here we are going to do some construction, right, for the betterment of our calculations, right? So let's make a line, right, that passes through this line that is based on the final position, right? So let's sketch a line that is passing through this line where it is parallel to the initial line, okay, or that is parallel to the initial radius, right? So now this line is parallel to the initial line. So then what is this angle? Delta theta, right? So first of all we need to identify this diagram, right? So now we'll see how to do that. So we are going to obtain the equation for the tangential acceleration, right? Tangential acceleration, right? Right. So now what is the tangential acceleration, right? That is the change in tangential velocity, right? That means the change in velocity towards the tangential direction, right? Divided by time taken for the change in tangential velocity, right? That means the required time taken for that change to happen, right? So now here we have to be very careful when taking the components, right? Because I will again tell you that now this is the original or the initial position, right? You got the point, right? This is the original, or in other words the initial position, right? And this P dash represents the final position, right? This is the final position, or in other words the current or the present position, right? Okay. So now these R represents the radial displacement, right, by considering this point as the center, right? So if I want to consider the present position, right, that is making an inclination of delta theta with respect to the original position, right? Okay. So now we have to find the change in the velocity but towards the tangential direction, right? So tangential direction is the direction that is actually perpendicular to the radial direction, right? But here you have to consider that this line that represents the radial displacement is not actually parallel with this line that represents the radial displacement of the present position, right? Okay, so that is the thing you have to understand, right? Okay, so now what is this direction? Or in other words, what is this radial displacement according to the original position? That is r, right? What is the radial displacement for the final position? So that will be, let's call it r plus delta r, right? Understand? So what is the initial radial velocity? R dot, initial radial velocity, r dot. What is the final radial velocity? It will be r dot plus delta r dot, or in other words let's call it final radial velocity, right? Okay, and what is the initial tangential velocity? Vt. Now see, this Vt is actually perpendicular to the now Vt is actually perpendicular to the line that represents the radial displacement, right? So now this is the final position, right? So now this Vt dash is the tangential velocity of the final position. Now see, this Vt dash is actually perpendicular to this line that represents the radial displacement of the present position, right? So now here we have to consider the change in tangential velocity, right? But be very careful, this line Vt and this line Vt dash are actually not parallel, right? But when we are going to consider the change, we have to consider one particular direction. That means we will consider the reference direction as the direction of this Vt, right? That means there will be components, right, that are actually affecting on the tangential direction of the original position based upon its components. You got the point, right? That means if I am going to consider the change in a particular direction, right? Because now this direction of Vt and this direction of Vt dash are actually not parallel. You got the point, right? Now see, if you are going to consider a construction line that I have mentioned over here, right, that is parallel to this one. Now see, this construction line is actually parallel to this construction line, parallel to this line, right? So then this angle will be delta theta, right? And if you construct another construction line that is parallel to the original position, right, so then what will be this angle? So we know that if this line is parallel to this one, this is delta theta, and if this line is again parallel to this one, then we know that this angle is also delta theta, right? So here we can see EZ angles, or in other words we call it alternate angles, right? So if this is delta theta, then what will be this angle? That will be 90 minus delta theta, right? Because now we have to consider the components, right, that are affecting on this vertical direction, or that are the components of the new tangential velocity that are affecting on the tangential velocity direction of the original position, right? So what is the first component? We know that this is Vt dash, this angle is 90 minus delta theta. So what is the first component? The first component will be Vt dash, right? Vt dash sine 90 minus delta theta. See this one, this component, the first vertical component. So what is the vertical component? Vt dash sine 90 minus delta theta. You got the point, right? Vt dash sine 90 minus delta theta. See, this is Vt dash, right? So this is the line that is parallel to the original position, right? So this angle will be 90 minus delta theta. So what is the vertical component? Vt dash sine 90 minus delta theta. Then there is an impact on the tangential direction, right, based upon the radial velocity of the present position also, right? So now what is the radial velocity of the present position? That will be r dot plus delta r dot, right? R dot plus delta r dot. Now see, so then this line, now this is the inclination delta theta. So now this line, right, represents, now actually this, the direction of the radial displacement of the present position and direction of the radial velocity of the present position, both are same, right? So then what is the component of the radial velocity of the present position that affects on the direction of the tangential velocity? So that will be r dot plus delta r dot times r dot plus delta r dot times sine delta theta, right, towards the upward direction, right? Because now if you are going to consider this radial velocity component, there are like two components, the horizontal component and the vertical component. So then what will be the vertical component, or in other words the component towards the tangential direction? That will be r dot plus delta r dot, that means in other words v r dash, right, the radial velocity of the present position. So that will be, so what will be the vertical component? V r dash sine delta theta, right? V r dash sine delta theta. So now this is the entire tangential velocity of the final position, considering the reference, or in other words considering the direction of the tangential velocity of the original position as the reference, right? Okay, minus, then what is the original value? Now all the time change is final minus initial. So then what is the starting or the initial tangential velocity of this position of the particle? So that will be Vt, right? I hope you got it right. So divided by the time taken for that change. So that will be delta, limit delta t tends to 0. Now what is Vt dash? What is the new tangential velocity? So that will be r theta dot plus delta r theta dot. Okay, r theta dot plus delta r theta dot. Okay, sine 90 minus delta theta will be cos delta theta. Okay, I will change the type of the bracket here, right? Okay, so this part is okay. Then Vr dot. Now what is Vr? What is the initial radial velocity? Initial radial velocity will be r dot, right? So what is the final radial velocity? Vr dash, that will be r dot plus delta r dot, right? So then that will be plus r dot plus delta r dot times sine delta theta minus Vt, we know what is Vt? R theta dot divided by delta t, right? So then limit delta t tends to 0. Okay, r theta dot cos delta theta plus delta r theta dot cos delta theta plus r dot sin delta theta plus delta r dot sin delta theta minus r theta dot, right, divided by delta t. Got the point? Right. I will erase the upstairs part. So then again limit delta t tends to 0, then we know that delta theta is very small, right? We know that delta theta is very small, right? So then cos delta theta will be what? That will be 1. If delta theta is very small, then cos delta theta will be 1, right? So it will be limit, right, delta t tends to 0, right? Now r theta dot cos delta theta, right? So now we know that this delta theta is a very small angle, right? So now if delta theta is very small, right? If delta theta is very small, right? So then cos delta theta will be, so this cos delta theta will become 1. So here we will be getting r theta dot, right? Now here we are having delta r theta dot cos delta theta. So here also, now we know that delta theta is very small, right? So then no problem, this cos delta theta will become 1. So here we will be getting what? delta r theta dot. Okay, right. And here when delta theta, right, as this delta theta is very small, right, sine delta theta will be what? Sine delta theta can be considered as delta theta, right? So this part we can write as plus r dot delta theta. Okay. Then this part delta r dot sine delta theta can be the sine delta theta can be considered as delta theta. So delta r dot delta theta, delta r dot delta theta. So I will put it like that. Right? Delta r dot times delta theta minus r theta dot. Okay. Divided by delta t. Right. So now you can very clearly see that this r theta dot, this r theta dot you can cancel. Right. So then what are the remaining components? Limit delta t goes to 0, we will be getting delta r theta dot, right, plus r dot times delta theta and delta r dot times delta theta divided by delta t. Be very careful to put limit delta t tends to 0. Right? So then here is this part, right? So now we can separately apply this limit operation, right? You got the point, right? Limit delta t tends to 0, right? Delta r theta dot divided by delta t. Got the point, right? So now we are going to apply this limit operation separately, right? Plus limit delta t tends to 0, r dot delta theta divided by delta t, right? Plus limit delta t tends to 0, delta r dot times delta theta divided by delta t. So now here we have that limit delta t tends to 0, delta r dot. Now this here, this delta r dot is a complete component, right? Be very careful. Now here this delta r dot is a complete component, right? So now this delta r dot times delta theta, right, can be considered as very small, right? But in the examination you have to write all these things, right? So this component we can neglect, right? Limit delta t tends to 0, delta r theta dot divided by delta t, right? This one, plus limit delta t tends to 0, r dot delta theta divided by delta t. Okay. So now this, here we have this limit delta t tends to 0. We have this statement, right? Limit delta t tends to 0, delta of this component or delta of this part divided by delta t, right? So limit of this component when delta t tends to 0, this component, right, if we have something, just recall the fundamentals. If you have something like delta y divided by delta x, where limit delta x tends to 0, that can be written as dy by dx, right? You got the point, right? So Now this part we can write as d by dt of r theta dot. Right. You got the point, right? That can be written as d by dt of r theta dot, right? Plus here this part. So this component you can write as, because here we have limit delta t tends to 0, r dot times delta theta divided by delta t, that can be written as r dot times d theta by dt, right? R dot times d theta by dt, right? Here, now again in here we have to consider the equation, you know, that d by dx of uv, right? The derivative of two things that are actually multiplied together, right? That means what? U times dv by dx plus v times du by dx, right? Based upon the fundamentals, right? I hope you got it now, right? First we will differentiate only r, that means theta dot times d by dt of r. So let's write like that: theta dot times d by dt of r plus r times d theta dot by dt, then r dot times d theta by dt, right? Now I hope you got it, right? So then theta dot times dr by dt will be r dot. First derivative of r with respect to time will be r dot, right? Plus here r, first derivative of theta dot with respect to time will be r times d theta dot by dt will be r theta double dot, because initially it was theta dot. Plus again here we have r dot, okay, r dot times d theta by dt will be that is the first derivative of theta with respect to time, so that will be r dot theta dot. So here we have r dot theta dot, here also we have r dot theta dot, so that will be twice r dot theta dot plus r theta double dot. So this is the equation, right? Twice r dot theta dot plus r theta double dot, right? So that is the equation, right? And this component is a very special part that we call as the Coriolis component, right? That is the Coriolis component, right? So this is how you derive that. So you have to practice this, right?